Good morning, class. Today we're going to learn about circuits 14, Kirchhoff's rules. Today we will be able to set up circuit problems using the junction and the loop rule, okay? So, in some situations, so far we've talked about series and parallel. In some situations, we may not be able to break a battery or a circuit down into series and parallel components. Sometimes no two resistors are in series or parallel. Sometimes no two resistors are in series or parallel, or we might have a situation where there's multiple batteries or multiple power sources. Okay, so if we have these situations right here, we're going to be using Kirchhoff's rule. Okay, Kirchhoff's rules, and those are two rules. First is going to be the loop rule. The loop rule. Okay, around any closed circuit loop, in a closed circuit loop, the potential drops equal the potential rises. Okay, and I'll explain what this means in a second. Okay, so that's in a closed circuit loop, the sum of the potential drops equals the sum of the potential rises. Okay, and now we're going to have the junction rule. The junction rule, J-U-N-C-T-I-O-N, junction rule. Okay, the sum of the currents into a junction equals the sum of the currents out of the junction. Okay, so if you look at this picture right here, if there's 7 amps going into the junction, there's going to be 5 and 2 coming out of the junction. The sum going out is equal to the sum coming in. Okay, so that's an example of the junction rule. All right, so let's do a couple problems here to put these rules into practice because they're a little bit weird. Okay, so notice here I have a circuit. I have a regular circuit and I have a 24-volt battery, I have a 6-volt battery, and I have 2 resistors, okay? Notice these batteries are going in opposite directions, okay? This battery is trying to go this way, this battery is trying to go that way. That's not going to make sense. Okay, so we have these two batteries, so we need to figure out how this is going to work. So we're going to use the loop rule, okay? Loop rule. Around any closed circuit loop, the potential drops equal the potential rises. Okay? So, I'm going to call this positive and negative right here. And I'm just going to say that the current is going this way. Okay? So we're going to say the current is going in this clockwise direction. Okay? So because I'm saying it's clockwise, I'm going to put these positive and negative signs here on these resistors, okay? Because it's going in this direction, it's always going to go from positive to negative, okay? So I want you to remember that a drop in potential means we're going from positive to negative, okay? So I'm going to start at this point right here, and we're going to go this way. Notice when we cross the path of this battery, we're going from negative to positive. So a potential drop is positive to negative, a potential rise is negative to positive. Okay, so potential rises equal potential drops. Okay, so this will be a 24-volt rise because it's going from negative to positive. Here, it's going to be a drop of well, we have to figure that out. So this is going from positive to negative. This is going to be a potential drop. So the potential is equal to V equals I times R. So this is going to be equal to I, we don't know what I is yet, times 12 ohms. Okay, equal to that. This battery, positive to negative. So this is also going to be a potential drop, plus 6 volts, plus going from positive to negative again. This is a potential drop. We don't know what the current is, so this is going to be I times 8 ohms. So when we put all this together, we're going to subtract 6 volts from both sides. We're trying to solve for current here. I don't think I said that at the beginning. 18 volts equals I times 12 ohms plus I times 8 ohms. We can factor out I times 20 ohms, 12 plus 8 equals 18 volts. I is going to equal 18 divided by 20, and this is equal to 0.9. 0.9 amps. Okay, so that is the current, and we found the current using the loop rule based on the rises and drops in potential. Okay, if my answer ended up being negative, if I had a negative answer, that would just tell me that the current is actually in the opposite direction. Because remember, we said based on this picture, the current's going clockwise. And we can just pick a direction. And if our answer would have been negative, what that really tells us is the current should be going counterclockwise. Okay, so let's do another problem here. We'll use a junction rule and the loop rule. Okay, so we have we have a 12 volt battery, a 14 volt battery. We have 3 resistors. Okay, this is a setup. This is a basic setup for a car battery, an alternator, and headlights. This is exactly how the circuit is set up. So notice here we have 2 currents coming into this junction, and once again we're just being arbitrary. Let's just call it this way again, clockwise. Why not? Okay, so we have IA coming in and IB coming in and IH coming out. Okay, IB is from the current from the battery. This is the current from the alternator, and this is the current going to the headlights. Okay, so we have an equation now. IA plus IB equals IH. Okay, so the currents going in equal the current coming out, equals the current coming out. Okay, so we know that we have a setup for that now. Now let's do the loop rules now. Let's look at this first loop, B, E, F, A. Let's look at this loop right here. So potential drops equal the potential rises. Potential drops equal the potential rises. I'll start right here, okay? Rises. And I just want to point out, this is a pretty complicated problem, so if you can do this one, then you can probably do all of them, okay? So, rises. We're going to have a 14 volt rise here, okay? 14 volt rise right there, okay? Drops. Notice this is going from positive to negative, so this is going to be a drop. This is going to be 0.10 ohms times the current through the alternator. As we come through this loop, this is going negative to positive, so this is going to be a rise. Negative to positive is going to be a rise. So negative to positive, we have 0.01 ohms times, I should put it on the air side, getting a little crowded over here. So these equal each other, and then this is also, and then we're going to hit this battery here. This is positive, negative. This is going to be a drop. So now we have an equation. We have the current through B. We have the current through A. We have the drops and the rises. So we have one variable B, one variable A, a second variable A, and a second variable IH. So we still have 3 variables. We have IA, IB, and IH, and we still have 2 equations. We can't solve 3 variables with 2 equations. We need one more. So let's look at this loop right here. Starting right here, this is going to be a rise of 12 volts. This is going to be a drop. This is going to be a drop, positive to negative. So 0.01 ohms times IB. This is going to be a drop plus 0.01 ohms. Oh, I'm sorry, 1.2, didn't see that. Times IH. And that's it. So now I have 3 equations, 3 unknowns, and now I can go through and start solving for these. Um, I'm not going to do all the algebra right now, but when I solve for these, I get IB equals negative 9 amps, IH equals 10.1 amps, and IA equals 19.1 amps. Okay. Now, when I solved all these out, I found that this is negative 9. So IB is negative. So it means that this really is going in that direction. Okay, that's really going in that direction. So that would be the answer to this. Once again, this is a very complicated question. This made us this I picked this question because we had to make three equations based off this one circuit. Most questions you're going to see are going to be a one or two step question, not so complicated as this. But I wanted to show you how to set up the equations to solve for this. Okay, so like I said, most multiple choice questions, if you see something with multiple batteries, it's going to be doing these types of questions. And so the first thing you have to do is just set up your equation, set up your loops, pick a direction, label your pluses and minuses to make it simple, and then go.